7.5.
It's not actually. It's an Android Lenovo.
Is that an
Solve
Android Lenovo?
special
Oh my.
types
No.
of linear systems.
Do not.
Keep telling me what.
Joey, I'm told you.
A linear system
I don't remember.
can have no solution or infinitely many solutions. If the graphs are parallel,
Oh, you're right.
then the system has no solution
You go throw a book at me? Do it. You'll get it.
and we call it
It'll expand your
Hey,
phone
do you mind writing your notes
In-
down, bro?
inconsistent
Write down your notes.
system.
Why did you get the highlighter to be so,
Oh,
like,
what?
smooth?
Whoa, wait. There's a highlighter on your iPad?
Yes.
Wait, do it. Oh,
It's so simple, dude.
Oh,
How
that's
do you not
cool.
know?
Oh, that.
Joey's never seen an iPad.
Move on.
Joey had an iPad.
If the graphs of the equations are the same line, then the system has infinitely many solutions and we call it a consistent
Wait, why is it highlighted?
Remember, because that's the importance.
Okay.
dependent system.
So if, like, if you, like, so if you solve it, and when you solve it, the lines overlap each other, then it's that.
Yeah, so you'll get something that'll be like, if you were doing the elimination method, you'd get something like 0 is equal to 0. And if that happens, there's infinitely many solutions because that means it's the same line.
So are we going to be doing, like, what method are we doing for this? Like, all of them are, like...
Some of them are going to be graphing, and some of them are going to be done by like elimination. I mean, substitution works, but I just don't think it's as good of a method. It's probably my least favorite to solve these kind. But you technically could do it.
It's my goal in life.
Parallel, all caps. Parallel. Underline that. I heard my neck's so bad.
That is a cool fact.
What, fishing?
No, I have whiplash.
From what? Fishing.
Oh, from jumping on a trampoline with my siblings.
I've jumped on trampolines just several times, and I've never gotten whiplash.
I don't know. Imagine having
If the graphs intersect at one point, then the system
All caps.
has one solution, and we call it consistent, independent system.
Inconsistent.
Okay, the hint to remember this one, independent, it's like it wants to be alone, so it's at one point.
I'll be alright. So first, you gotta act like an absolute champ.
All right, with the
Do that. So,
infinitely many solutions, you get a statement that is always true. For example, -4 is equal to -4, 0 equals 0, 100 equals 100. Okay, those are always true statements. So if you get something like that, it's infinitely many solutions. For something to have no solution, you get a statement that is always false. So something like 0 is equal to 5, 10 is equal to 20, -3 is equal to 88. Okay, something like that. That's never true.
Could you go up a little? Because I can't see the. Yeah.
Do we have all these notes written down so I can go up?
I do. I will.
All right.
I don't know.
All right. Number of solutions. And slopes and y-intercepts. Okay, so this is going to be for the case where you are given the system written in slope-intercept form. Alright, so if you have one solution, you just have different slopes.
Okay. Yeah, I did this in Miss Earhart's class. Mrs. Earhart's class.
If it's no solution, you have the same slope with different y-intercepts. And if it's infinitely many solutions, the same slope and the same y-intercept. Number of solutions of a linear system. Alright, so if you have a graph like the first one, there's one solution. Like the second one, there's no solution. Those are parallel lines. In the third one, it would be infinitely many solutions. Because it would be the same line just stacked on top of each other. So at the first one, the lines intersect. Second one, the lines have different slope, or sorry, still the lines have different slopes. Second one, the lines are parallel. And then the lines have the same slope and different y-intercepts. The last one, the lines coincide, okay, meaning they're on top of each other. The lines have the same slope and the same y-intercept. Huh?
Who drew the flower before?
I have no idea.
You just got there.
Just appeared there one day. Usually happens in like homeroom, so.
It's a good looking flower.
Thank you, Audrey.
No, you didn't.
I stuck with him.
Joey. Oh, I thought you were gonna do
Get your mind down and make better.
What was going on? Is he like Joey?
Yeah.
Alright.
That's versus.
Graph the linear system, then use the graph to tell whether the linear system has one solution, no solution, or infinitely many solutions. Alright. Number 8. We have x plus y is equal to negative 2 and y is equal to negative x plus 5. So what do I need to do to that top equation to be able to graph it?
You have to move the x over.
Move the x over. So that one's going to be y is equal to negative x minus 2. And then I still have y is equal to negative x plus 5. Alright, so it says to graph it. So that's what we're going to do. Alright, so the first one, y-intercept of the top one,
Y-intercept will be negative 2.
negative 2. And it's got a slope of what?
Has a slope of either down 1 over 1 or I don't know what you could do the other way.
Up 1, back 1.
Yeah.
Alright, y-intercept of the bottom one,
X
5.
plus y
5.
equals.
Oh my god.
and the slope,
2.
The
Y
slope is the same as the
equals
before. Show me.
negative x plus 5.
Joey's
That's
so
parallel,
smart.
so isn't it like ultimate solution? That would make sense.
parallel, do they intersect anywhere?
No,
So there's no solution.
that's what I meant.
No solution.
Sweet home, no
Remember when we sang that in spiritual emphasis?
Alright, number 10. 3x minus y is equal to negative 9.
Okay.
3x plus 5y is equal to negative 15. Alright, so I need to rewrite these equations. So how do I rewrite the top one?
Are we doing which one are we doing? Wait, are we doing graphing or are we doing graphing?
Yeah, still graphing.
Move the 3x over.
So negative y is equal to negative 3x minus 9. So then I need to divide by the negative. So that's going to give me 3x plus 9. And just move this one down and write it over here. So this is equation 1, and I'm going to rewrite equation 2. Alright, so what do I need to do to get y by itself in the bottom one?
Wait, that's not my food.
What do I need to do to get y by itself in the bottom one?
Yeah, you move. Okay. So smart.
Okay, now what?
And then you gonna divide by 3.
You should divide by 3.
Oh wait, no, never mind. I'm gonna divide by 5.
Divide by 5.
Sure.
So y is equal to negative 3/5 x minus 15 divided by 5 is 3. Alright, so this is my new equation 2. So now I need to graph those.
Hold on. Let me just write them. No, wait, that one.
Alright, so graphing equation 1, what do we get? Or where do we start?
You start at, for which one, top one?
Yeah, for equation 1.
15, negative 15. Because negative 15 is the way.
For
Wait.
equation 1?
1 and 2.
Oh wait, no, wrong thing. Negative 9.
Negative?
I'm really confused. What problem were we on?
5
And
Number 10.
equals.
Well, I
See
don't
how
know,
this
but what
is-
equation? 1 or 2?
1.
9.
Okay, positive 9. And what's the slope?
3.
Ooh, it's a
So I'm gonna go, instead of going up and over, I'm gonna just go down and back. So 1, 2, 3, and back 1.
I thought you could do that.
Well, you can.
Good job. If I get sunflower seeds, I'll be good. If I get sunflower seeds, I'll be good.
Sweet pea. I mean, sweet pea.
Oh wait, you knew that
All right, equation 2. Where do I start
too.
it?
Okay, can you tell me how you graph that?
Yes, I got the y-intercept, which was 9, and I plotted that on the y-axis. And then I did the slope. I went down 3 and back 1 because it's technically up 3 over 1, but
So you
I needed
can-
to go back to fit it on my graph.
To pick like 1 or 2 equation.
No, we're gonna graph both of them,
I'll go both.
just like 7.1. We just now have an option other than one solution, which is what we're looking for. We don't need to know what the solution is, we just need to know how many there are in this section. Well, for this part. Alright, equation 2, how do I graph that one?
Negative 3.
Go down to negative 3. And slope.
Negative 3 and 5.
Okay, so I'm gonna go up 3 and back 5. Okay, since it's negative, just trying to fit it on here. And I'm just gonna do these 2 points just because. Okay, I can't, hold on. I'm just gonna stand up and
Get what?
move.
Wait, so to be here,
Wow, I feel really bad.
I have to go with Chris.
Yes.
I mean, you're wrong.
How you looking at it? So I'm adjusting.
Alright, so how many solutions does this one have?
No, you can't wear it on your head.
How many solutions are here?
1. Wait.
Yeah, 1.
Why?
Because they
Is it
intersect.
they want to
But
intersect?
they're not the same line.
They intersect at one point, but they are not the same line, so it is one solution. Alright, number 12. Negative 9x plus 6y is equal to 18, and 6x minus 4y is equal to negative 12. Alright, I need to rewrite. How do I rewrite the top one?
move over both of the x's. I mean, like, on both points, you can move the
Okay,
x's.
yes. I'll do this one first. So 6y is equal to 9x plus 18. And I'll go ahead and do this one down here.
Let's do the one.
All right, now how do I get y by itself over here in this one on the right?
And then you just divide by 6.
Divide by 6. So y is equal to 9 divided by 6, which is going to be 3 over 2. X plus 18 divided by 6 is 3.
And you do the same thing for the other one.
I'm going to divide by negative 4 over here. The y is equal to 6 over 4 is going to be, well, they're both negative, so it's going to become positive. So 3 halves x, negative 12 divided by negative 4 plus 3. What do you notice about these?
They're both right. Oh, they're the same.
They're the same
Whoa.
line.
If you already know it's the same, do you need to graph it?
It has an infinite amount of solutions. I don't think.
Nope.
Same.
Same line. I'm not even going to make you graph it if it's the same line. You just need to tell me that it's how many solutions then.
Just give us like all same line.
Yeah,
How many solutions?
1.
What?
I mean, 2. I mean, all of the above.
Infinitely many
I
solutions.
was
What I
right.
meant.
I was right.
Shut up, Chris.
I haven't been right with any of these, so
Joey
I felt
bullies
good.
you, so I believe you can do it.
Okay. I'm going to make a note that when they are the same line, you do not have to graph it.
Yay.
All right. For the rest of today, because then I'll have a few left that I can go over tomorrow with them here, with everybody else back. And that way you will have had me for everything you need for the quiz. I'll make sure there's a lot of review stuff before that and answer keys to them here for whoever's here. Need to do 9, 11, and 13
That's it?
Yep.
What page?
on page 463. Okay, and then tomorrow we'll finish this section, and then I'll talk a little bit about tomorrow what to expect with the quiz and answer any questions from 7.3 to 7.5. Remind me to go over that worksheet tomorrow as well. And yeah, that'll be good.